Good morning and welcome back to our class. Our topic for today is least common multiple and it will be explained well. For our objectives for today, we have number 1, determine the least common multiples of a set of a number, and number 2, use different methods in determining the least common multiple of a set of numbers. So let us consider this problem. Oscar has some flowers which he can give to 3 or 4 of his teachers. If he gives the flowers to each of the number of teachers, they should receive an equal number of flowers. What is the smaller number of flowers that Oscar has? So how do we solve this problem? Any idea? Okay, in order to solve this problem, we will use the idea of least common multiple, or what we call LCM. The LCM, or least common multiple, of two or more numbers is the smallest multiple common to them. So there are three methods that we will use. So the first one is the listing method. Say, for instance, find the LCM of 3 and 4. So I would like to list down some multiples of 3. So I have the following numbers: 3, 6, 9, 12, 15, and 18. While for 4, I have the following numbers: 4, 8, 12, 16, 20, and 24. And take note of the least, or the smallest multiple. So I'll encircle the smallest, which is actually 12. So therefore, the least common multiple of 3 and 4 is 12. Let's have another example under listing method. Say, for instance, find the LCM of 4 and 6. So I list down some multiples of 4. So I have the following numbers. Okay, and also I'll list down the multiples of 6. So I have here 6, 12, 18, 24, 30, and 36. But take note that I have two common multiples, which are 12 and 24. But I'll encircle the smallest one. So therefore, the LCM of 4 and 6 is equal to 12. Let's have another example under prime factorization method. Okay, so find the LCM of 20 and 25. So first, we will list down all the prime factors of 20. So namely, 2 times 2 times 5. Then for 25, we have 5 times 5. Then, we will encircle the common factors, so which is actually 5. Now, to get the LCM, so notice that 5 is actually the greatest common factor of 20 and 25. Then, to get the LCM, so that is GCF, or the greatest common factor, times the remaining factors. So what are the remaining factors? So the remaining factors are 2, 2, and 5. So we will put it here. So LCM is equal to 5 times 2 times 2 times 5, or the least common factor is equal to 100. Let's have another example under prime factorization method. So say, for instance, find the LCM of 24 and 36. First, I'll list down all the prime factors of 24. So namely 2 times 2 times 3. While for the prime factors of 36 are 2 times 2 times 3 times 3. Then I'll encircle the common factors. We have 2, 2, and 3. So the LCM is actually, so that is the greatest common factor. So we have here 2 times 2 times 3 times the remaining factors. So what are the remaining factors here? So the remaining factors are 2 and 3. So the LCM is actually 2 times 2 times 3 times 2 times 3, or this is equal to 72. So let's move on to the next example. So find the LCM of 18, 24, and 30. First, I'll list down all the prime factors of 18, 24, and 30. So I have 18 is equal to 2 times 3 times 3. While for 24, we have 2 times 2 times 3 times 3. And for 30, we have 2 times 3 times 5. Then encircle the common factor. So we have 2 and 3. Take note that the LCM is actually the greatest common factors, which is actually 2 times 3 times the remaining factors. So what are the remaining factors? So the remaining factors are 3, 2, 2, and 5. So again, LCM is equal to 2 times 3 times 3 times 2 times 2 times 5, or equal to 360. Let's move on to the third method, which is decomposition method. In the decomposition method, we continuously divide a set of numbers continuously until the final quotients are 1. So say for instance, find the LCM of 16 and 24. Again, we arrange the number 16 and 24 horizontally and divide it by prime number 2. So we have the quotients 8 and 12. Again, divide the quotients 8 and 12 by a prime number 2. So we have the quotients 4 and 6. Again, we divide it by 2. So the quotients are 2 and 3. But take note that 2 and 3 are prime numbers. But again, I'll divide it by 2. Okay, so 2 divided by 2 will give me 1. Since I cannot divide 3 by 2, I'll simply write 3 here. So, we have 3. Next, divide the quotients 1 and 3 by a prime number 3. So, the quotients will be, okay, since I cannot divide evenly 1 by 3, I simply copy 1. And 3 divided by 3 will give me 1. Okay? So, since the final quotients are 1, so therefore, the factors of LCM are 2 times 2 times 2 times 2 times 3. Or I can rewrite this as horizontally. So I have 2 times 2 times 2 times 2 times 3. So the product is equal to 48, which is the LCM. So let's have another example. Find the LCM of 24, 36, and 48. Again, we will arrange 24, 36, and 48 horizontally and divide by a prime number, which is 2. So we have the quotient 12, 18, and 48. Then divide this again by a prime number 2. So we have the quotient 6, 9, and 12. Then divide this again by a prime number this time, which is actually 3. So we have 2, 3, and 4. But I can divide 2, 3, and 4 by a prime number by 2. So I have 2 divided by 2 will give us 1. Since I cannot divide 3 by 2, so I'll simply copy 3. Then 4 divided by 2 will give me 2. Then divide this again by 2. So since I cannot divide 1 by 2, so I simply copy 1 as well as 3. And 2 divided by 2 will give us 1. And then divide the quotient again by 3. So the final quotient is actually 1, 1, and 1 since I cannot divide 1 by 3. So the factors of LCM are 2 times 2 times 3 times 2 times 2 times 3. So I can rewrite this one horizontally, then multiply. Therefore, the LCM is equal to 144. Again, the LCM of 24, 36, and 48 is 144. To summarize our discussion, the least common multiple is the smallest common multiple to a set of numbers. So we can either have the listing method, the prime factorization method, or we have the composition method.